Okay, so we are talking about normal form in the context free grammar. So, we have seen one normal form which is CNF. Now, we will talk about GNF, which is Greibach normal form. This is of the form, suppose G is the grammar, and if all the rules are of the form like this, A is going to A alpha, where A is a terminal and alpha is coming from string of variables. A is a terminal, alpha is coming from string of variables. So, this is alpha could be epsilon also, because this is a string. So, in that case it will consist of all the rules like this, and also if this is, if epsilon belongs to this language generated by this, then we have a rule S is going to epsilon. So, that will be there. So, if our grammar is if the productions are of this form, then the corresponding grammar is called in a normal form, and this is called Greibach normal form. The quick example we can take, suppose we have grammar like this, the rules are this A B or epsilon, and A is going to B C, capital C, and B is going to B, and C is going to small c. So, here the V is A B C, and the terminals is small a b c, and S is the starting variable, and this is our P. P consists of these rules productions. This is in Greibach normal form, because every rules are of this form. A is a variable, any variable going to some A alpha, where alpha is belongs to, and here since this we want to generate the epsilon, then we have to take the rule S is going to epsilon. So, this is of this form, this is terminal, this is variable, this is terminal, and this is variable like this. So, this part we have all the variable. If we have a rule like this, A is going to say A B B C. So, this is not in Greibach normal form, because this part is not belongs to V star, because we have a terminal over here. So, this is not in Greibach form, GNF. Okay. So, now in general not every grammar is in this form. So, we have to reduce the grammar in this form, because this will help us to prove the we will see the push down automata, which will accept the grammar in this form. So, we will see that part later on. Okay. So, we want to convert every grammar in GNF. So, for that similarly we can first eliminate the null production and then the unit production, and we can convert in CNF first, then from that we can convert to GNF, or directly we can do that. Okay. So, for that we will be using two lemmas, mainly we will be using two lemmas to convert reduce to GNF. Given a grammar G, we want to reduce this grammar to some G prime, which is in the form of GNF. So, for this we need to use two lemma. Lemma 1. So, lemma 1 is telling, suppose we have a grammar G, which is V T P S, and suppose we have a rule like this, alpha 1 B alpha 2. Okay, B is a variable, alpha 1 alpha 2 could be anything, like it could be a string of variable, and this could be a string of alpha 1 alpha 2 could be anything, like alpha 1 alpha 2 are coming from Okay. Suppose this is a production in P. and we have a B production. This is A production in P and we have a B production in P like this. B is going to some beta 1 or beta 2 dot beta r. Now, we want to suppose these two are not containing any beta, or maybe we do not bother about that, but this B we want to remove, we want to eliminate this B. So, for that these two production, I mean set of productions, we can say these two rules, set of rules, we can replace this grammar. We have many other rules. So, this grammar we are going to replace by G 1, which consists of V T P 1 and S 1. So, P 1 all the rules will be same of G, only thing these two rules we are going to replace by a new rules, like we want to eliminate this B, like A is going to so we are going to add this, A is going to, so B is going to this. So, if you put B over here, so A will be going to alpha 1 beta 1 alpha 2 or alpha 1 beta 2 alpha 2 dot alpha 1 beta r alpha 2. This is the, so these two production we are going to replace by these productions, and we can easily verify that these two grammar will be same as generate the same grammar, because see we are just going to replace this B by this B's rules. These are the B's rule, B's production, this is the S production. We do not want B to be here. So, that is why we are going to replace all the B's production into the S production. So, this is referred as lemma 1, this process, and we can prove that in the lecture note, the detailed proof will be given. These two grammar are same. Okay. So, we want to just eliminate this B variable by the all the B's production. This is called this process is called lemma 1, and then we have another process which is called lemma 2, which will be also useful for the converting the grammar to a GNF. Lemma 2 is telling, suppose we have a grammar G, V P P S, and suppose we have this productions, A is going to A alpha 1, A alpha 2 A alpha r, and also we have A is going to beta 1 beta 2 beta S. Okay. And these betas are not starting with A. So, betas are not starting with A. So, these are all strings, string of variables and terminals. This A is a variable. We know this type of, so A is going to this type of rules are not allowed in the GNF, because GNF must start with a variable terminal followed by the variable. So, we have to we have to change this, we have to remove this. So, this lemma 2 will be is the process to change this. So, how to change this? So, we can see A is going to this, then we can just have a, so if A is derived A from A we can derive say A alpha 1, then again we can apply any one of this rule, say A alpha 2 alpha 1, then we can derive any of this rule like A, or finally this A we can replace one of these betas, say beta j, and followed by some alpha 1 alpha like this. So, everything will be converted this. Okay. So, now here this betas is not having any A, that is our goal. We want to remove this A from the rule. So, for that what we can do? We can bring a new variable called z, and we can introduce the z production like this. So, yeah, so we will keep, so these two will be replaced by so this one can be written as like this. A is going to, this will be remain same, this we have no issue, because they are not, these betas are not involved to any A, starting A, and A is going to beta 1 Z, because this we are going to represent by Z, which can be generated. We have a Z production, beta 2 Z dot 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 beta S Z. This is the A production, and we have a Z production like this. So, Z is going to alpha 1, alpha 2, because Z is, role of the Z is to generate the string of alphas. So, alpha 1, alpha 2, alpha r, and to generate the string of alpha we need to have this one, another rule, Z is going to alpha 1 Z, alpha 2 Z, alpha r Z, alpha r Z. So, this is the rule. So, this can be derived by this way, because A is going to alpha 1 Z. So, then we can apply this by getting that. So, eventually this lemma 2 is telling, eventually this grammar will be replaced to this grammar, where, so this is the given grammar, so TPS, and we have these rules. These rules we are going to replace by this rule with the new grammar G prime or G1, where we are introducing a new variable Z and remaining are same. And in P1, this was in P with some other rules. In P1, this type of rules, A production will be replaced by this type of A production along with this type of Z production. So, this will be in P1. So, other will be in the P, other will be in P1. So, then we can show that the grammar generated by G is same as grammar generated by G1. Okay. So, is this clear? So, this is basically we want to get rid of the starting A, because our GNF is not allowing any starting A. So, for that we need to take help of another variable Z, for which this has no issue. So, this will be remain same, and this will be so they will be, each of these will be ending with some beta I. So, beta I, and Z will be, we will use Z to have a string of alphas. So, that is by this rule. So, this A production and this Z production will be added here in P1 along with the, so only for this we replace this by this A production and Z production. So, this is called lemma 2. Okay. Using lemma 1, lemma 2, we can reduce a grammar to a GNF. So, that we will see. So, yeah, so the proof is there in the lecture note. The rough idea of the proof I have given. So, let us take an example of this lemma 2. So, suppose we have this gamma, A is going to A, B and BB and C, small c, and we have another rules with A, which is having A involved, AD. Now, if you compare, this is our beta 1, this is our beta 2, this is our beta 3 and this is A. So, this is our alpha 1, this is our alpha 2. Now, so this is our G. So, G is consist of V, T, P, S, where V is A, B, this, and we have S. So, we are just talking about only these productions where this is going. So, this will be replaced by G1, which is V union some Z, T, P1 S, and P1 will be all the rules which does not involve this, and these two will be replaced here by this. So, A will be going to, we have no problem with this, A, B, D and C, small c, and we have a production like this, alpha 1 z. So, alpha 1 is this, beta. So, sorry, beta 1 z. So, beta 1 is this. So, A, B, D, Z, then B, so B, D, B, Z and C, Z. This is the A production, and the corresponding Z production is, so Z is going to alpha 1, alpha 2 and their recurrence. So, alpha 1, alpha 2 or their recurrence, alpha 1 Z and alpha 2 Z. Okay. So, this is the rules, and we can show that these two will generate. So, these two production will be replaced by these 4 productions. 2 is A production, another modified A production, and this is Z production. This A production was remain same, but this we are changing, we are introducing a new variable Z. Okay. With the help of this 2 lemma, we can show, we can reduce a grammar to the GNF form. So, that algorithm we will know, but basically we will be using lemma 1 and lemma 2. Okay. So, for this, suppose we have given a grammar G. Now, step 1 first what we do? We rename the variables by A1, A2, AN. We start with S we rename A1, and then if we have a rule like this AB, so S we are renaming A1, A we can rename at A2, A3 like this. So, we have basically the variable set A1, A2, AN, and A1 is basically S. So, that we are doing. So, this is our V, this is our grammar, and T is remain same, we are not disturbing T, and A1 is the variable. Okay. We are renaming the variable. Now, in the step 2 we want to do what? We want to modify the production such that AI will be AJ gamma if J is greater than I. So, this will be there. So, we want to have a modified rules or modified production such that if AI going to AJ gamma, then this J must be greater. That means, A2 is must going to some A3 gamma, something like that, but A3 should not go to A2 gamma, because this 2 is not greater than 3. So, for that we need to do something, we need to apply the lemma 1, lemma 2 like this. So, we will do like this. Okay. Now, if so, first we check whether whether all the productions are like this. If all the productions with starting with the variable are like this, if not, this is for, if not, if there is a production like this such that AK is going to AJ gamma, where gamma is where J is less than K. If there is a production which is violating this, then we have to do something on this production. What we will do? We want to change this. So, how to change this? We will apply lemma 1. So, just apply lemma 1 to remove this, to remove AJ, and then we will see whether we are getting or not. So, we will repeatedly apply this, okay, until we got this type of check. So, this is step 2. Now, in step 3 we will apply lemma 2 there. So, for that we check this. So, in step 3 what we do? So, in step 3 suppose we have a variable like this, a k is going to a k gamma. Okay. So, this is we have a k production, a k is the variable. Now, we know this type of things is not allowed in GNF. So, what we have to do? We have to apply lemma 2. So, we have to introduce the new variable z, if you remember, and then we can apply the lemma 2 to get this. So, this is the step 3. Now, repeatedly applying this, what we get? So, after step 3 we will remove all this, we will take an example. We will be having this type of form, ai is going to aj gamma, where j is greater than I, and ai is going to a gamma, where a is belongs to t, and we have introduced the z variable for applying lemma 2. So, this is z is going to this, where z is coming from v, and we have introduced all the z variables like this, maybe z I 1 star. Okay. So, up to step 3 we will be having, we will reach to this situation. Now, we have to check the we have to apply step 4 and step 5 to finalize this. So, step 5 is step 4 . Step 4. Okay. Step 4 is, so we have the all the production like this. So, n is going to a gamma. So, that is fine, but we have a minus 1 production, there we may have like this. So, a minus 1 is going to a gamma prime, we will not do anything, but what we do, a n minus 1 is going to say a n gamma prime, something like that. So, this we have to change, because this is not allowed in GNF. So, what we do? We apply the lemma 1. If we apply lemma 1, this we can apply here, and we can change this to a n is going to a n minus is going to some b like this. Okay. So, this may be in GNF, and we will repeat this process up to a 1. We will repeat this process up to a 1. So, this is step 4, and step 5 is we do the same thing with the z production. So, we modify the z production by applying the lemma 1. Applying lemma 1. So, these are the 5 steps, and this we will do in the step 5. So, we will take an example, then it will be more clear. So, there are basically 5 steps, but basically we are applying lemma 1 and lemma 2 repeatedly. Okay, let us take an example. Suppose we have we want to convert this gamma, convert the gamma to the GNF. What is the gamma? S is going to AB, and A is going to BS or B, and B is going to SA or A. This is the given gamma, and this is, we can easily check, this is not in GNF form. Okay. So, we can first we can eliminate the null production, and we can eliminate the unit production, then we can convert this in first CNF, but we can directly convert into the GNF by applying this 5 step. Okay. So, what we do? Step 1. Step 1 is we can eliminate the null production, we can eliminate the unit production, we can convert into CNF. Then we can rename the variable. So, this we are going to rename as S1, S is S1 is going to S is A1, A1 A2. So, A1 is S and A2 is A, A3 is B, like this. So, and A1 is going to, so A1 is going to this, and A2 A1 A2 A3 and now A2. So, this A2 is going to A3 A1 or B, and A3 is going to A1 A2 A. This is step 1. We rename the variable by A1 A2 A3. Now, we check step 2. Step 2 is we check all the productions whether AI is going to AJ gamma where j is greater than I. So, this is okay. So, we can add so this A1 production, A1 is going to A2 A3, these are in required form, and A2 production, A2 is going to A3 A1, this is also in required form along with the B, and A3 production, this A3 production which is going to A is in required form, but A3 production this is not in this form. So, this is not in this form. So, A3 which is going to A1 A2 is not in this form, because this is 1, this is not greater than 3. So, we have to apply lemma 1 here. So, we do that. So, let us apply lemma 1 here for this, for other it is okay. So, we will just let me just erase this. So, we have to do something for the this A3 is going to A1 A2. So, this we have to change. So, we replace this by using lemma 1. So, we replace this by following A3 is going to. So, we check all the A1s where it is going lemma 1. So, A3 is going to A2, A3 A2, as A1 is going to A2 A3, this is production in A1. Okay. Now, this is also having problem, because this is 2, this is 3. So, now we are going to replace using the A2 production. So, if you do that, it will be like A3 is going to, we are repeatedly applying the lemma 1. A3 is going to A3 A1 A3 A2, then B A3 A2. Okay. So, this is one. Now, okay. So, now resulting production is like this. A3 is going to, we have the A3 production there. So, A3 is going to A or A3 A1 A3 A2 coming from here, or B A3 A2. Okay. Now, this is the A3 production. Now, in this is the step 2. Now, in step 3 what we do? We check all the production like this, like here this A3 is going to this one A3 A1 A3 A2. So, this is you have to change, we have to introduce a new variable z that will change this. So, to do that we have to bring this alpha beta gamma, and so then we can check that this will be like this. So, let me just write A3 is going to A, this is our beta 1, A3 A1 A3 A2, this is our alpha 1, and we have B A3 A2. So, we are just applying the, this is our beta 2. Okay. So, if we apply the lemma 2 for this, so we are introduce a variable Z3 say. So, A3 is going to A, B, A3 A2, just we are applying lemma 3, A Z3 and B A3 A2 Z3, and then Z3 is going to A1 this alpha 1, A1 A2 A1 A3 A2 and alpha 1 Z, Z3 sorry, A1 A3 A2 Z3. Okay. So, this one alpha and Z3. So, this way we continue, this is the step 3 and step 4 again we repeat. So, this is step 3. So, in step 4 what we are doing? So, now in after step 3 we have the all productions in the format of this A I is going to A j gamma, where this is not same as this. So, now so we have some A n is going to this. So, so that we will be doing in here. In step 4 if we apply A3 production, A3 will be going to A or B A2 A3 sorry A3 A2 and A Z3 this one and B A3 A2 Z3, these are all in the required format. And for the this is, and for A2 productions what we have, A2 is going to A3 A1 and B. Okay. Now, we retain this A2 is going to B, this is okay, this is of the required form, but this we have to change, we have to do something on A2 is going to A3 A1. So, then we will apply lemma 1 again. So, A2 is going to A3 A1. How we can change this? We know this A3 is, we know the A3 rules, we apply lemma 1 to change this. So, that will be like A2 is going to, so this will replace to, we apply the all the A3 rules. So, so B is there, so B is there. So, A1 then A3 A1. So, this one A1 then B A3 A2 A1 like this, all the rules. So, this is the lemma 1. So, we will keep on apply lemma 1, then this is step 4, we will do it for all, then the step 5 if we apply for this on the Z variable we will check and finally, we will get the required form. So, the details will be given in the lecture note. Thank you very much.